Class activation maps highlight the parts of the images that the neural network focuses on, so we can better understand how our neural network works in supervised learning when we reach that stage. Camps give us an idea of what part of the data has to be focused on by building a heat map. When we worked with the VGG16 architecture, the output seemed to focus more on the heart area than the rest of the lung skin. The model also didn't have the best accuracy. When we worked with the ResNet architecture, our output highlighted the ground glass opacity in the lungs with a much better accuracy.
PCA was able to successfully reduce the dimensionality of our data. For most test cases, 99% of the variance was able to be recovered while dropping a majority of the components. However, no immediate conclusions can be made, but doing this can help quicken the training of our supervised learning models. This is because if fewer components have to be analyzed, fewer computations have to be made, and thus our training time will decrease while still yielding an accurate model. This could help with both unsupervised and supervised learning tasks, like DB-scan and neural networks.
For DB-scan, we were hoping to be able to segment the different sections of the lungs for easier identification of COVID. We encountered some issues such as DB-scan was crashing my computer if I didn't scale the images down. In addition, the epsilon parameter is extremely sensitive and has to be recalibrated for each individual image in order for clustering to occur. For the most part, DB-scan clusters by lung boundaries and non-lung boundaries, but it's probably not the best way for reducing noise and segmenting the portions of the images just because the epsilon parameter is too sensitive and it's drastically different from image to image.
My GMM implementation was able to successfully group colored images, but I'm experiencing an error in which I transformed the size of the pixel NumPy array. The issue stems from the fact that the implemented algorithm was using strictly colored images to group the colors within that image, but our dataset is using grayscale CT scans. I am planning the workaround to be modifying the array transformation such that the dimensions of the array fit for that of an image with grayscale dimensions. Additionally, I will be using sklearn's public domain implementation of GMM in order to eliminate the possibility that the error is stemming from an incorrect implementation by me. I have, however, been able to group colored images as shown below. Once these issues are resolved, this will allow us to see the differences in images between positive and negative scans and draw conclusions about what aspects of the positive images indicate the existence of COVID.
In terms of data cleanup, we grayscaled the images, we converted JPEG to PNG because the file types were inconsistent, and in preparation for supervised, we also have a setup to convert all the images to 224 by 224 for training.
Overall, we worked with 4 different algorithms that helped us understand the dataset more thoroughly, and we currently have a pre-processed dataset that will aid us in both unsupervised and supervised learning tasks.